I decided to get a jump on this really quick to see if I can get things set up. I'm actually trying a new broadcast streaming software. It's actually it's built on OBS. It's from Streamlabs, and it's built on open broadcasting software. But it's got a ton more special features, and I want to make sure that I kind of get acclimated and then I get a chance to try them out. I'm hoping that this works better in the long run than using the original version of OBS. I'm also hoping that my stream is looking clear and you guys can see everything okay. That is the hope. Let's see what else we have here. I'm just trying to check out the special features of this new software. So those are all the special messages. Doop. I don't know if there's a way to view the stream chat here, but I've got my phone open, and so the moment you get here, if it's possible, just say like a quick hello in the Twitch chat, because I'm curious if the Twitch chat will show up in any way that I can see. That's what I really want to see. So it'd be helpful if you could do that for me. Just a quick test to make sure that it works the way I think it does. All right. Oh man, oh man, oh man. Holy smokes. What a week we've had, right? This week we started talking about design, and it's going to feel like we've put the brakes on, like we've really slowed things down. And it's not really that we've slowed things down at all. It's that we've taken a step back from just doing, from just throwing stuff together, from just slapping code together until it works. And now we're taking a moment to really plan through what it is that we're trying to do. We're trying to be intentional, right? And beforehand, we would look at requirements and we talk about what we wanted to do, and then we kind of think about it in our brains. Then we would just throw stuff up into our IDE in the hopes that it would work well. And that is not the way real engineers work. Side note, thank you very much, Mr. Merriman. I see you in the chat. On my phone, I've got the chat going live on my phone, so I'll be able to respond there. What happened was that last time we did a Q&A stream, I didn't have any way to monitor the Twitch chat, and there were a couple people who are not in our daily classes at Newmont College, and they were asking questions, and they were good questions, and I was trying to figure out some way to contact them and to answer their questions. One person asked a question. It was one of those things where I was like, you know what? If you took 10 seconds and Googled, you'd find the answer to your question. But another person had a much more broad question. It's actually, and it ties directly into what we're doing today, which is, I don't even know how to start. I don't know where to begin. And what he meant was, when he knows how to code. He's been coding for 4 years, and he knows how to do object-oriented programming, but whenever he's given a new project, he doesn't have a process for how you actually begin. And I got a chance to talk to him directly. He is a student off in the East Coast, and he was very gracious and generous and agreed to just talk with me on Discord in a voice chat. And I got a chance to talk to him about the process of starting a project. I got to ask him what he normally does. And what we found out was that after 4 years of being taught how to code, only when he was a freshman did they ever introduce him to the notion of UML. And from that point on, they never upheld the standard. And what's interesting is that in the field, in the industry, having a design plan, having documentation, having wireframes for the UI, having... And for us software architects, having a UML diagram, an ERD, a flow diagram, just something that expresses how these complex objects interact with each other is vital. That is everywhere in the industry. Then UML stands for Universal Modeling Language, and it's a grammar. It's a diagramming grammar for expressing the architecture of your code. It doesn't talk about, how do we implement the code in terms of, okay, I'm going to raise an int x to the power of y. There are so many options for how to do that. We could either talk to the already existing math class. If we don't have access to that, we could create a loop, or we could be recursive, or we could do really silly addition. We could do, there are so many ways that we could raise one int to the power of another int. But UML doesn't talk about that. UML simply says, here are the classes, the enums, the interfaces. In each of these classes, here are the data fields. In each of these classes, here are the methods. And here's, here, this class owns instances of that class, and class B calls methods in class A. It's all about architecture, and it's all about integration of these types, how they interact with each other. So in other words, the analogy that I use with my students is that, whenever you're building your dream house, for example, you don't simply give the requirements to a builder who then goes off, gets a pile of materials, brings them back, and just starts slapping stuff together until they get some gross approximation of what it was that you requested. A real builder listens to your requirements, asks clarifying questions, and then draws up a plan, draws up a blueprint, and says, based on this plan, where these walls connect, and this door is in this position, and this is how you get from the great room to the dining room, and this is how you get to the basement, and here's where the windows are, and the plumbing, and the electrical. And once they have that plan laid out, they can look at it and they can say, does this work? And if the answer is yes, then using those plans, they bring in their contracting team and they build the foundation. They build the skeletal structure of the house. They determine what materials to use. They'll put a roof and sheathing and all that stuff on the house so that it becomes a structure. But then when it comes to making the place a home, when it comes to making it actually function as a living space, that's when we go into the interior decorating mode. And interior decoration, in terms of drawing that analogy back to software design, interior decoration is our pseudocode. Pseudocode is where we go in to all of our methods and then we start making comments about how are we going to do this. Yes, I know based on the name of the method and the class that it's in, I know what job that method is supposed to perform. I know what one thing this method is supposed to accomplish. But now the question becomes, how does it do the job? How does it accomplish that thing? That's where pseudocode comes in, because then we use the pseudocode to say, step by step, here's my recipe for raising int x to the power of int y. And that recipe can take many forms. So that's why we have the pseudocode there to kind of lay it out so that we know what our plan is. So UML is like the architectural design of software. And pseudocode is the implementation design of software, the external versus the internal. All right, talked your ear off enough about that. We need to practice doing some UML design. We got to figure this thing out, right? And it occurs to me that I had a couple of examples in my head about what I wanted to do here. Unfortunately, I do these as assignments at certain points. And so I'm debating whether or not we should do this. But I'll tell you what, let's see, I like that example so much, but I don't think I want to do that. I'm not sure I want to do that today. Let's come up with something else. Oh, you know what? I usually do a movie collection assignment when I teach OOP, or I use that as an example, because I don't know if you knew this or not, but I used to be a film student, and I'm a huge movie buff. And so I want to make sure that, that I know what I'm talking about when I'm doing examples. So I often choose movies because movies are ideas that are very easy for me to understand and comprehend and dissect and decompose. Just really quick, I'm hopping over to the Discord server to make sure that I'm not missing any chats or comments there as well. And Inspirify says that they like UML. Yes, you know what? Every programmer should learn about flowcharting. And especially as a visual learner, so we haven't talked about flowcharts in my class yet. And flowcharts are about making choices. They're about making decisions. And what I like about flowcharts is that it helps you map your logic. That flowcharts kind of start to straddle the line between UML and pseudocode, right? Because UML is about the architecture of the classes, the way that the members are declared. And pseudocode is about how those members are implemented. Flowcharts give you a map of, okay, I'm in this state of the application, or I'm in this state of the class, and I make this change, what happens? Or I ask this question, based on the answer, where do I go? For example, if we were to do something with days of the month, where based on the month and the year, if we want to do leap year, based on the month, we're going to figure out how many days a month has. A flow chart could help us make that decision. It very much mirrors the architecture of a switch statement in many cases. Not always, but a switch statement or an if-else if, any of those logical things, loops, any logical construct maps directly to a flow chart and vice versa. And so, yeah, we haven't practiced flow charting in my class yet. You make a very, very good point in Spirify. And so that might be something that I should probably look into showing my students. All right, so let's go ahead and let's move into some example stuff here. So, you know what? I've got this picture-in-picture thing going so that you can see my face when I'm talking about this. Give me just 1 second because let's see, where did my editor go? There's my editor. I think I'm going to move this element over, primarily because it's right in the way of what we're doing. Wow, this element, you know what? The picture-in-picture is probably a bad idea. Never mind. Change my mind. We're just doing this. You don't need to see my face. You know what I'm doing. You know what I'm about. So here we go. All right. I am using a program called UMLET, or UMLET. I believe it's pronounced UMLET. And I like this program because it is completely free, and you can get it as a standalone application. The standalone application I prefer because while UMLET is designed to integrate with Eclipse, it is also something that I use with other applications and other technologies. I use it with my C# development in Visual Studio. I use it for back-end and even front-end web development design. I use it for database design. I use it for a lot of stuff. And like you were saying in Spirify, you could even use this for flow charting. So I use it for a ton of stuff. When you go to download UMLET from the displayed URL, if you go to the umlet.com website, you'll find a download link on the left-hand side, and you'll be able to get either the standalone version or the Eclipse plugin. If you get the Eclipse plugin, there are some advantages. For example, once your diagram is finished, it will create a stub of all those classes and types for you, which is great for the most part. You might have to go in and change a couple things that UMLET didn't properly translate. But I still prefer the standalone version because I use it for so much more than just Eclipse projects. Do what you want, but this is the version that I like. Also, it's not an installed application. It literally is a standalone application. That means it's an executable that sits on your system, and it relies on neighbor files for its information, but it does not install itself into your OS. It does not register itself in the key registry. It doesn't leave a big footprint. If you ever want to uninstall the app, all you have to do is find the folder that you're running it from and just delete that folder with all of the UMLET with its contents, applications off of your system, no big footprint to worry about. So I like the standalone version a ton. Okay. Now, I'm just kind of curious. Hang on a second. No, I didn't. Okay. So again, I'm using new broadcasting software. It is built off of OBS, which is what I was using before. It's a version of OBS, but I never mapped my hotkeys for transitions, and so I have to click back and forth kind of frequently. Sorry about that. Hey, Mr. Merriman, I didn't know you used to be a film student too. You've never told me that. That's awesome. All right, so here we are in our UML diagram, and first things first, we need to come up with the actual requirements of what it is that we're trying to build, right? And let's say for a moment that I want to make a movie collection manager, right? And we're going to try and keep this as super simple as possible because I just want to show the principles of movies. Of UML, of movies. The principles of UML. So, and thanks for the flowcharting vote there, Mr. Merriman. So here we go. Let's see. Requirement number one. Requirement number one, spell things correctly, because I used to be an English major and it bothers me when I misspell stuff. Okay. User can add a new movie to the collection. right? And in fact, to kind of sum this up, we might even want to just refer to this as CRUD. User, because what we'll do is we'll do like user can create or add a new movie. User can view an existing movie in the collection, right? And then this is what we call CRUD controls. User can update an existing movie in the collection, and user can, of course, delete. User can delete, and then we'll just do this, copy that down here, an existing movie in the collection. This is what we call CRUD, where you have create, read, update, delete. Read just means to see the data that you've already got stored. And so we have CRUD controls for a movie. We should probably talk about what a movie is, right? So a movie object has, and then we'll do, let's see, title and year of release, rating, and we might even talk about how ratings are only G, PG, PG-13, R, NC-17, unrated, and not rated. Something to that effect. That way we know what kind of values we're expecting on rating. We might also have something like the director. And we can come up with a ton of other stuff, right? Since we are in a movie collection, it makes sense to me that I would want to grab this stuff and instead kind of bump it down. And by the way, that's going to be, look, I'm making a mess, and I know that. Because in a collection, I'm going to want to have an ID. In fact, this is going to be a collection ID, basically, right? I don't mind just calling it an ID, but it's just a numeric collection ID. The first movie added is 1, next movie is 2, and so on. Okay, so this is our movie collection. We want to be able to add stuff, view stuff, update, delete. Sounds great. We should also be able to view, so that's view an existing movie in the collection. We also should be able to, let's see, I'll just come down here and add this as a new one. View the collection as a list, meaning that I want to see the whole collection at one time. And we could even talk about viewing the list by ID versus viewing the list by title. I'm not too worried about that because I just kind of want to get the basics of UML down using this, right? So here are our requirements. And you know what I'm going to do? I'm going to go ahead and just grab all this text. And when we hop over here to UMLit, I'm going to go ahead and just, let me just drag that. Okay. I'm going to go ahead and just add like a note over here. I'm going to grab a note object that I can use to just kind of view my requirements. Some of my students do wrestle with color blindness, so I'm going to get rid of this blue background because that's trash. And then we'll just paste this. So here is our requirements list. Notice that the indentation does not translate into the diagram here, which kind of sucks. I think there's a way to make that work, but I don't have, I'd have to look that up just to make sure. Let's see. What happens if, oh, I can just space it, so there's that. 1, 2, 3, 4. Great job. And then we'll just, I don't know, that doesn't work. All right, fine. Undo. And then, let's see. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And this one. 1, 2, 3, 4, 5, 6, 7, 8. Yay! And then just a little bit more, just to make sure this is readable and understandable. 1, 2, 3, 4. There we go. All right, so now everything is indented. We're good to go. Life is good. Remember that at any time, if you want to ask any questions live and on the air and you're on the Discord server, please go ahead and specify that in the questions channel. And my mods who are online will move you from the questions channel to the the waiting to be moved channel, where I will see that there is someone who wants to ask a question live, and we can stop what we're doing and we can handle that. So if you have a question you'd like to ask live on the air, as it were, please let us know in the Discord server, and then we will add you to the voice queue. Just put in a vector. Gosh dang it, Inspirify. You and your vectors. All right. So here is our movie collection stuff. Great. So how are we going to represent this as a class diagram? Now, since we are learning object-oriented principles in Java, I'm going to start with the low-hanging fruit. Or actually, you know what? First, let's talk about this for a second. Let's talk about this for just one moment. So remember, if you were in my class, then I talked about the notion of top-down decomposition versus bottom-up decomposition. And what I talked about where that was concerned was, given some problem, given any problem in computer science, every problem, unless it is an elementary or atomic problem, is actually composed of smaller problems. And the idea is, if you can solve all the little problems, you'll ultimately solve the big problem. To kind of rephrase a quote by a pool legend, Minnesota Fats, Minnesota Fats said, if you take all the easy shots, there are no hard shots. Meaning that if you just shoot all the simple shots, you'll eventually clear the table and you'll win. If you solve all the little problems, there are no big problems, because all big problems are composed of small problems. So when you're talking about decomposing a problem, you can go top down or bottom up. Top down says, imagine that you can see the whole picture, that you can see the problem in its totality. From a zoomed out perspective, the problem looks like this. But as you zoom in, you can start to see the components. Or the modules, I should say. Once you see the modules, you zoom in a little bit more, and then you can see the components of each module. Once you go into those components, you can see the classes that you need, or the interfaces. And then as you zoom in a little bit more, you can see the data fields, the data types that we need. And that might mean that we need some enums involved. And then you zoom in a little bit more and you can see the methods and the functions and how they operate. And eventually you get down to the most atomic parts. That's top down. Bottom up says, start with the smallest thing possible. The smallest thing possible. Define it to its completion. Absolutely. Once that thing is done, move to the next smallest thing. Once you go to the next smallest thing and you define that to its completion, go to the next smallest thing, and so on. The idea is, if you'll start with the tiniest pieces first, you'll use those pieces to help define the larger pieces. And if you keep defining larger and larger in your scope, you eventually define everything that you need to solve the entire problem. And as I pointed out in my class, there's no one who just thinks one way or the other. They might prefer one way to the other, but they actually need both ways of thinking at all times. For example, if you're going to build the smallest thing in an application, you first have to be able to identify the smallest thing in an application. How can you do that? Well, first you have to think through the application, and then you have to think about all the parts, and that means you have to see all the different modules, you have to see all the different components and all the different classes until you get down to the smallest things. So really, to do a bottom-up approach, you first have to do at least a very brief top-down analysis to even identify what the smallest things are. So with that in mind, you're going to see me kind of jump between let's define things generally versus let's define this thing specifically and all the way to its completion. For the most part, I'm going to attempt to do this from largely a bottom-up perspective. I think that after having done this for so long, that it's easier for me to kind of think of the parts that have no dependencies. They don't depend on anything else, and create those things first. So let's do the low-hanging fruit. Let's do the obvious stuff first. First, I'm going to be doing this in Java, and I know right away I'm going to need a driver class. I'm going to need a driver class that has a main method. And remember that main methods are static and public and void. In UML, we make things static. Well, in UML, you make them static by underlining them. And in UML, we underline things by bookending them with underscores. So I'm going to put in 2 underscores and then back my cursor up. You might notice I'm down here in the properties editing. You can drag entities into the design area, and then you can select an entity. That's why this is blue. And then in the properties in the bottom right corner, this is where you make all the edits and the changes. And so I named the class driver just by typing in the word driver. I created these visual separators by adding single hyphens, which also if you add double hyphens, it does the same thing. That used to be the way you had to do it in UML. And then they simplified it to 1 hyphen. I kept one line of white space here just so that I would know there would be some visual space to make it readable. And then in this third section where we put methods, I'm going to put the main method. And we need an underline there, which starts and ends with an underscore. So I've got my 2 underscores. I've backed my cursor up to be between those underscores. Plus means public. And then the name of the method is main with a lowercase m. It has a parameter list where we have a parameter called args of type string array. And this method returns void. So this class, wow, look at that. Exact width. Yeah. This class, this is all it does. The whole purpose of the driver is to hold the main, and the whole purpose of main is to get the application on its feet in its starting state and then take its hands off and get out of the way. So this is a very, very simple class, and we like that. That's what we prefer. Okay, so now we've got our driver class. Now I'm thinking through this. You know, we've got a movie, and a movie has all this data. I could start with the movie class, because I acknowledge that a collection ID, that's just an int. A title, that's just a string. Year is just an int. But then rating gets special. Rating is actually a specific set of values. Anytime I have a specific and finite set of values, values that have specific meaning, and I need to make sure that this data field is relegated to one of these values, that is a surefire recipe, a surefire sign that I need an enumeration. I need an enum. And enums typically are completely independent things. I can define them by themselves because they're not dependent on some other object or some other data type. And so I like to start with my enums first. If I know there's going to be an enum, I like to start with an enum first. So I'm just going to put it right over here next to driver. And I'm going to open this thing up, and we're just going to call this thing to make sure it doesn't get confused with rating in terms of score, like 5 out of 10 or 3 out of 5 or whatever. We're going to call this MPAA rating. The MPAA, the Motion Picture Association of America, or let's see, Motion Picture Arts Association, whatever that thing stands for, I forget now. This is the body, this is the board that gives movies the ratings of G, PG, PG-13, and so on. Now, because this type is an enum, we're going to go ahead and label it as an enum. By the by, I have noticed that many UML diagrams will take this kind of annotation if it says interface or enum or abstract, and it will place it above the class name. And I'm okay if you do that. I have no problems with that. I actually kind of prefer it beneath. I don't know why, but I think it visually looks better, and I find it more readable. This is a class because there's no annotation. This is an enum. Here's the type of that enum, and then right here I'm like, it's like an aside. It's like a whisper. It's like, it's an enum, you know. And so I kind of like it underneath, but you can see that it looks fine above as well. In fact, some people might prefer that because then they can easily and very quickly identify all the enums by looking at the very first header. I like it underneath. That's where I'm putting it. All right. And in an enum, we list all of the valid values. And we should probably list this in a sequence that makes sense, in a sequence that that determines precedence of some kind. Usually, if you have any notion of a default value, that's the first thing you should have. In Java, enums are reference types. Since enums are reference types in Java, they can be null. And by default, if you don't assign a value, that enum variable will be null. To that end, if I want to specify that we don't know how this film is rated. We don't know if it actually ever went before the board and received a rating, and we don't know if it never went before the board. So because we don't know, we could say that unknown is a valid state, and in Java, the best way to express unknown is just null. So, I'm sorry, I've got the hiccups a little bit. Okay, they're gone now. So, in order to represent unknown, as in I don't know if it went before the board at any time, I don't know that it did, I don't know that it didn't, I'm going to allow null to represent that. With that in mind, is there another value here that I want to do first? Well, not rated is having never gone before the board. I feel like that should be the first one listed. So using proper Java convention, Because this is, I know UML is language agnostic, and that's actually one of the beauties of it. But this UML diagram is intended for a Java application. So I can insert some Java conventions and still be okay. For example, since all values in an enum are static constants, I'm going to go ahead and say not underscore rated, all in capitals. That follows the Java convention of listing constants, particularly static constants, as all caps. Comma, to separate this value from the next value. Oh, hey guys, special guest star. Come here, buddy. Special guest star. Come here. Quick, 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 quick. Look right up there. This is my son Luke. Say hi.
Hi.
So there are people online right now listening to me teach. Okay?
Mm-hmm.
All right. I'm going to keep teaching. Okay?
Yeah, I want to hear.
All right, you go ahead. I love that kid. All right, so after we have this value, we have a comma. We separate it from the next value. Next value we will say is, we'll just go up the line from this point, from G all the way up through NC17. So G, PG, PG13. You can't use hyphens in Java in an enum because the enum value is effectively a variable name, and variable names cannot have hyphens. They can have underscores, but not hyphens. Brother, please don't do that. Hey, brother, look at me. Look at me. Shh. Okay? Because I'm teaching. Okay? I know, brother, I know. He's frustrated, and that's okay. NC17, and then finally, unrated. For those who might not know, unrated means at one point in time it went before the board. It went before the board and it got a rating, but then they changed after they received a rating, they changed the content of the film. And by changing the content of the film, it nullified the previous rating, and so the rating got removed. That's what makes a movie unrated. They add scenes and sequences that change the nature of the rating, but they don't put it before the board to get a new one, so it's just unrated. Hey, brother man. No, you cannot. I'm working. Remember what I said about that? Why don't you go upstairs and play games upstairs with Mom?
But can I play this game upstairs?
He's down here. My wife just figured out where my son is. Sorry for the interruption, folks. I'm sorry. But I'm not sorry that you get to see my kid because I love this boy.
Luke,
Hey, brother, what game did you pick?
Is this one?
Let me see. My son and my daughter have good taste. If you haven't ever played this game on PS3, it's great. All right, Luke, go upstairs with Mom. You can't play that one upstairs. That doesn't work. It doesn't work upstairs. It only works down here. I'll help you play it later, okay?
He's down here.
Okay, so
Feldman,
take him
5,
upstairs.
4. Thank you. Misha, come.
All right, so back to this. So, sorry guys. So here is our enum for the rating, okay? This is a type that stands all on its own. It doesn't depend on any other type, but it is going to be used to help us build our movie type, and that's why I defined this first. So now that we've done that, let's go ahead and define our movie class. Our movie class has all data types that now, thanks to this enum, currently exist, and there's nothing else. So let's go ahead and drag and drop another simple class. Also, remember that you can double click to clone it into the diagram, but it'll put it up here in this upper left corner and it'll overlap, and I just didn't want to do that this time. So here we're going to make the movie class. Remember, we always define classes. If we're going to have a class that makes instances of an object, we always define it in the singular, because if I can make one, I can make a million, right? So we always define it in the singular. So here's a movie, and practicing proper encapsulation, we're going to have a private title string, and we will have a private year, meaning year of release, int, and we will have a private rating. And if you want, let's see, let's just call it rating. I'm fine with that. And that'll be of type MPAA rating. And then finally, we have a director, which is, for right now, we'll just make that a string. If I were making a real application and I was adding a ton of details, I would probably have an actor, or, you know, I'd have some person class that defines actors, directors, producers, that sort of thing. Okay, cool. And then make our separator. And then, because we are practicing proper encapsulation, we are going to make some getters and setters. But first, we ought to determine if any of this data should be constant. Once received, should any of this data be allowed to change? And we have to ask the question, given a single movie with a a singular release, like the Star Wars that we saw in 1977, they did do a re-release in 1997. However, when they released it in theaters in 1997, it had new scenes, new special effects, it had a lot of new stuff. And they actually called it Star Wars Special Edition. So it actually had a different title. The title, Star Wars, in 1977, that relationship never changed. You could argue that when it went to home video, Star Wars became Star Wars A New Hope. But that was the video release in 1983. Or 1980 or 81, or I think it was 83 or 82 when it came out on VHS for the first time. So we could argue that since we're only trying to represent movies that we can own, movies that are on disc or movies that are digitally purchasable, we could easily delineate between original release films versus when they're turned into director's cuts or unrated or whatever. So we could argue that the title of a given film never actually changes. If we agree that title should never change, then we can simply mark that as const for constant, or we could say final if you want to be a little bit more Java specific. To be honest with you, I don't remember exactly how to mark something constant in UML. I think you make it bold. Let's take a really quick check. UML constant, right? So how to represent constants in UML class diagram. If I go here, then they're like the goal of a class diagram is document relationships, blah, 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 between classes, as well as how objects to those classes can change. The key elements are relationships, operations, and state. A constant does not fit into any of these elements. I can see what they're saying. They're talking about object relationships. I get that. However, whether or not something is constant is useful to know in a UML diagram. It is an implementation decision, I get that. But I am curious if there's a way to indicate constant otherwise. So let's take another quick look. UML class diagrams, and blah, 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 blah. Attribute as constant. Pure UML, let's see. So I guess it is related to a specific language or, okay. Is a constant, or you want to specify that it's constant or final if you are targeting. Okay, so based on what I'm seeing here, very briefly, whether or not something is constant is sort of unimportant to UML. And I can see why. I get it. Might be why I don't remember how to make something constant, because it's not a thing. Let's see. Hang on a second. UML cheat sheet. Here we go. Package interface class, some inheritance, some association. My dog is in the room. Yay. Yeah. Okay, cool. So we can do whatever we want here. And that actually means that what I did here makes a lot of sense. I do want to make sure that this is labeled in a way that tells me this is going to be a constant field, because that really does determine how choices I make later when I'm actually creating this class. The year of a movie should never change. It gets released once, and then, while we may have re-releases later, or we may have different anniversary editions or director's cuts or whatever, it's not the same film. So I don't mind making this a final release here. That's perfectly fine by me. MPAA ratings. Surprisingly, ratings do change over time. That's why we have it unrated. That's why at one point in time, Gremlins was PG. I think they may have upgraded that to PG-13 in recent history, because Gremlins, I saw that as a child. And let me tell you, dude, that was not a family film. Well, it kind of was, but it was like a family horror film as opposed to a family fun Christmas film. And at the time, I don't remember if they had PG-13 yet or not. PG-13 was invented about the time that Temple of Doom was released. So anyway, point is, they gave the movie a PG rating, and it was like, whoa, this is way creepier than PG. Anyway, they may have since changed the rating, but I have seen movies over time change their rating status. So because that may change with time, I'm not going to make that final. The director, believe it or not, surprisingly, we could argue it changes, maybe? I don't know. Here's an example, and I may argue myself out of this. the original 1980s Dune film adaptation of Frank Herbert's Dune, with Kyle MacLachlan and Patrick Stewart and a whole bunch of Freddie Jones and Brad Dourif and Francesca Annis and all these other people, right? Like, just great cast. That film was originally directed by Dino De Laurentiis, I believe it was, if I'm not mistaken. No. I take that back. It was produced by Dino De Laurentiis. It was directed by David Lynch, I believe. Is that right? Now I gotta know. Gosh dang it. I can't be wrong about these things. It makes me absolutely nuts. So now I gotta go check if it was Dino De Laurentiis or David Lynch. I want to say it was David Lynch. But the point is, when it was in its original cut and it went to theaters, director is David Lynch. So, okay, all right, I eventually got it right. David Lynch directed it. But then the fandom was so huge around it. It was such a great version of the book that they eventually made a special edition where they took it from like its 2 hour and change length and they made it like over 3 hours long. It was like this super long edition of it. I forget exactly how long it is. I have it. Super special edition, all these added scenes. And when that happened, it changed the vision of the film, and David Lynch was not happy, and he didn't like the cuts and the edits that they made. And so he refused, there goes my dog, he refused to keep his name on it. And so they did what they do in Hollywood whenever a director does not want to take credit for a film. And they said it was directed by Alan Smithee. Alan Smithee is a completely fictional person, and Alan Smithee has more directing credits than any single director in the history of Hollywood. So the question then becomes, do we have two different movies here, directed by two different people, and therefore the director never changed? Or do we have one movie where the director changed? Based on what I just said about how the movie was released in a special edition with new scenes at a different time, so it wasn't even the same movie, I'm going to argue and say it's two different movies. And because it's two different movies have one director, or, we can, for the purposes of our app, we're only tracking one director. And that director never changes. So let's go ahead and make that director final. See the kind of thoughts we have to go through as an engineer? We have to think through this stuff. We have to know what's going to change and what's not. Because when a field is final, that determines where and when it can be set, or if it can be set at all, right? And also, when a field is final, we can choose to maintain proper encapsulation through the standard means of having a public, get title that returns a string. We can do that. Or, since this is a final field, it is completely safe now to make this public. Because once it is set, it can only be set in the constructor. And once it is set, it can never be changed. Since it can never be changed, it's okay to make it public because it's safe. No one can mess with the data. We could just say, hey, give me movie.title. And it will give us that title all the same. And it's kind of an interesting situation. But, I think let's see, what's the better part of valor here? Let me think about that. Let's see, movie, constant, diddly-diddly-doot. It also couldn't hurt to do both if you really want to. There's just no point. I'm going to say, because, to reduce any confusion, I'm going to go ahead and just maintain proper encapsulation through the normal get title, especially if we decide later on that title should not be a constant. Then if we ever decide to make this a variable instead of a constant, then we won't have to go back and refactor a whole bunch of code to start calling get title, something that we didn't have before. If we have it now, then that code never has to change. However, because title is a final, it cannot have a set. So we just move on to the next thing. Let's do get year. And then let's do get rating, which returns an MPAA rating value. That one is not final. So let's go ahead and call set rating, passing in a rating of type MPAA rating. Returns void. And then finally, again, director is final, so we're just going to have get director, which returns a string. Okay, nice and easy peasy. Chances are I'm going to want some easy way to display a movie, or at least to get its state, if only for testing purposes. So I'm going to go ahead and add a toString method here, which of course returns a string. And again, since this is for a Java project, it's important to note that this is an override of an existing toString declaration. So we've got our 4 fields, we've got these gets and sets, we've got this toString. You know, we've got some constants here, and they're instance constants. So because I have instance constants, guess what I absolutely positively have to have? I have to have a constructor. I have to. So let's go ahead and add a constructor here. Remember that constructors don't follow the same convention that other methods do. They don't have a return type. They're not static except under extremely specific circumstances. They're almost always public except under extremely certain circumstances. And so we're going to go ahead and just say public. It's named after the class. It has a parameter list that we need to fill in. Let's go ahead and pass in title of type string, year of type int, and rating. Oh no, I'm sorry. The rating can change. It's the director of type string. You may notice that this method, this constructor, only takes in the constant data fields, the data for the finals, right? And that's intentional in this case. Also, because this is a constructor, there is no return type. However, I like to be really explicit here. I like to make sure that people understand. The whole point of a UML diagram is to communicate. So we need to make sure that we're clear. And in order to be clear, I like to label my constructors. And I do that with a double angle bracket CTOR. That is the accepted industry shortcut, the shorthand for constructor. By the way, I'm looking over at the Discord server, and I don't see any questions in the questions channel. I haven't looked at general or help in a little bit, but I don't see any new messages there either. So once again, if you don't post anything in the Twitch chat, I'd prefer it in the Discord chat, but if you're not there, put it into the Twitch chat anywhere if you have any questions, and I should be able to see it. But I'm mostly expecting to see text questions in the questions channel on Discord. All right, so moving on. So here is a constructor that takes in those final fields, right? We could argue that this is an acceptable constructor, and we could have a second constructor that is very similar. So I'm just going to go ahead and copy this, come down here and paste. We could have one that's very similar, except it also accepts a rating of type MPAA rating. What we're saying here is that there may be cases where I want to build a movie in the application and I don't need to know what rating it has, or maybe the rating is unknown. And so instead of passing in null, I'll just call the first constructor without a rating. Or maybe I know what the rating is and I can call the second constructor with a rating. In my opinion, this is kind of overkill. At this time, this is not a significantly different enough scenario. There are scenarios where you would have multiple constructors because they are significantly different, but not this time. I'm going to go ahead and just get rid of this first constructor and keep the second, so that we have year. We have title, year, rating, and director. Okay. All right. So then we let's see. This constructor is going to set these values. These getters will allow us to get those values. We have one setter that allows us to set the value at any time in the history of this object, whereas the other 3 fields have to be set during the construction phase. And then we have a toString. To be honest with you, as a POJO, as a plain old Java object, this is complete. This is all we need for the movie. Yes, I can see that we should be able to add and view and update and delete, but this is the part of the application's behavior, not the movie's behavior. Now, there is a question in the Discord. There is a student working on their Hangman project, and they're not sure how to convert their answer key into underscores and revealing a letter when the user guesses it. I was wondering if we could learn about how to do something like that. Oh, that's a good question. That is a good question. And what makes it so good in this case is I want to come up with an example that is not me just directly doing your homework, right? I want to make sure that if I give you an example, the principles hold up, and then you can apply the principles to the problem that you're trying to solve, and that I don't just solve the problem for you. But I bet you I could come up with something. Hang on a second. Let's see. You know, that's really eerily close. But what can we fudge. I'm thinking about a possible example that would answer your question. What could we do instead? Well, I could show you a few different examples that are a little bit disjoint, but would show you how you could interact with these items in a way that's meaningful. And then you could take those interactions and use them to your advantage. That's what I could do. And then someone brought up just a moment ago, they said that I talked about string.split. Let's talk about what string.split actually does. I'll tell you what we'll do. First, let me do one tiny thing in UML, just one small thing that'll get us to a good pause point. And then I'll start addressing your questions, because there's some things I want to talk to you about Hangman anyway, and string.split is one of them. So let's go ahead and do that, okay? So let's do UML first, just a little bit, and then we'll get to your questions. Here we go. So now we have a driver. That's going to kick the application off. We don't even have the manager yet that we're going to need for that. We have a movie class. In fact, I'll do this. I'll move this down. We have a movie class, and the movie class has certain data fields. One of those data fields is of a custom data type. Remember that whenever we declare a class, we declare a new type. And whenever we declare an enum, we're really just declaring a new type. This is a variable, not a constant. This is a variable of type MPAA rating. Whenever we have one class or entity that is built out of another class or entity, in this case it's an enum, but whenever it's made up of another custom type, that is a relationship that is either referred to as composition or aggregation, both of which mean to be made up of something else. This movie is made up of strings and an int and this other custom type. Now, whether it's composition or aggregation has to do with the way that the memory is managed behind the scenes and who's responsible for destroying what. In truth, in Java, it's telling the difference between the two is extremely difficult and may actually be a moot point because it's managed memory. In other words, it's managed for us. So I often just stick with this default. I believe this is actually a composition pointer. If I'm wrong, it's an aggregation pointer, but either way, I'm going to go ahead and drag this onto the field. The diamond touches on the object that is bigger, or rather the one that is made up of the other, right? In other words, this movie class owns an instance of MPAA rating. You could look at this and you could say, well, movie is the richer class because it owns an instance of the other class or the other type. And so you can also look at this as the stick portion, this diamond on a stick. This stick portion touches the singular element. The diamond portion, the reason it expands and then contracts again is because it symbolizes that you're taking several other types and funneling them in to another single type. So the diamond goes on the movie because the movie is in charge, or we say that the movie is composed of an MPAA rating. We would do this if this data field were a single rating like it is right now, or an array of ratings, or a list of ratings. We would say that movie is composed of at least one rating. So that's what this symbol means. And this says that movie owns an instance of rating, MPAA rating. Hopefully that's clear. Now what we've done is, we've got this driver, and it's about to have a relationship with another object, but we haven't defined that other object yet. Just so that we have a placeholder, and then I'm going to stop once I have this placeholder where it's supposed to belong. I'm going to call this the movie collection manager. And this is the smart class. This is the class that has all the brains. This is the one that's going to fulfill the first 4 and the 6th requirement, right? This is the one that's going to do all the heavy lifting. Also, chances are, since I'm making this a console app, chances are I'm going to be using my console IO library. Since that is a library that I've already created and it's somewhere else, I can make a simple reference to it like so. I can even, if I really want to, I can say that this is a library. Or rather that this, I could, if I wanted to be very specific, I could say it's lib dot. In other words, I could attach the package to it, lib.console.io. And this is part of another external library. Because of that, I don't have to specify the methods. I don't have to specify the data fields. I can just have this here because I know I'm going to use it. Okay, let me add my separators really fast. There we go. All right, so some good placeholders here. We'll come back to this later, okay? In fact, I'm going to go ahead and save this really fast. I'm going to call this Movie Manager Demo. There we go. I'm just going to go ahead and hit save. There we are. So now I have saved off my design as it currently stands. We'll come back to this in a little bit. Let's change gears for a moment, and let's talk about important things involving Hangman, right? I'm going to make a new demo here. And by the way, let's see, where are we? We are 56 minutes in, and we are changing gears. Yay! Maven project, next, create a simple project, good job. I'm going to use the video code demo group in this case. And my artifact ID is going to be string manipulation. All right, there we go. Makes this groovy little thing, and then I open this up, and I'm going to grab all the low-hanging fruit. Oh, wait, hang on a second, it's not finished. There we go. And I'm going to add a new class, which is going to be my driver class, which is going to exist in my app package that doesn't exist yet, but will in a moment. And I click finish, and bada bing, bada boom. Bang, there it is, right? I've got this package, I got this class. And I'm going to go ahead and add a new class to a not yet existing controllers package. You guys have done this with me before. And we'll call this, I'm just going to call it the demo class. And of course, I'm going to give it a public static void run method that we're going to kind of experiment in. And save that, come back over here to driver and make sure that the main method calls demo.run. And just to make, just to make life a little easier once we have some real code, I'm going to go ahead, Control-Shift-O to get the import. I'm going to go ahead after I've saved everything. I'm going to go ahead and hit play. Nothing's going to happen except it compiled the code and it executed the code. Main called demo.run. Demo.run has nothing in it, so then the application returned back to main. Main has nothing else, it closes. But by doing that, now when I'm over here and demo has focus, when I hit play, it'll run the right main method. All right, a little bit of water. And here we go. You know, I'm going to go ahead and add, really quick, I'm going to add a private static buffered reader Buffy. That is the new buffered reader, and it has a new input stream. Side note that has nothing to do with anything. You know, I used to take television and film classes, and that was in the same department where they did radio classes. And I had been told multiple times, hey, you should have a morning show. You should have a radio show. When I would work with certain people and I'd be funny, and they'd be like, you'd have a great show. What's funny is I started looking into radio stuff for just a little while, and I came across the term puker that one of my favorite DJs used to use. Whenever you have a radio DJ that sounds like this, it's like their words keep getting stuck in their throat and they're just puking them out at you. I totally believe in that, and I hate that. There is a guy that works at a local movie theater, and I like him as a person, but he has the most signature radio voice. And he knows it, and he uses it to his advantage, and he will totally ham it up, and it makes me want to vomit every time. He's like, All right, your movie is over in theater 14 and you're going to be in row J and you've got in row J. That's how he talks every time and it makes me nuts. So if you ever hear me do that, it'll be very briefly and usually ironically. Here we go. All right, so I'm going to have a string. First, just so I know what's going on, I'm going to go ahead and sys out and we'll be like, enter something. And since I'm using that as a prompt, oh my gosh. Guys, what the crap am I doing? What the crap am I doing? I don't need to make a buffered reader. I'm going to be prompting the user for stuff, right? What am I doing? Oh, God, Mr. Krebs. Mr. Krebs, what are you even thinking? You see, for those of you who are not in my class, we have a project that we do where we build a library all about how my life got flipped, turned upside down. No, all about how we take, how we give prompts and take an input. It's all about that. And I have this nifty little library that for the most part is exactly the functionality that I want. So I'm just going to grab this and I'm going to drag and drop it into my string manipulation. Usually I would just, I could actually build a link to this thing, and it's probably wiser if I do it in case I ever update this library. So yeah, I'll just make a link to it this time. My students are required to copy it over, but that's because it helps with grading. It makes grading possible. But since I'm not giving this project to anybody else, I can just link to it. Here is my jar. I'm going to right click it, add to build path, and now it's part of my code. Now I can go to demo and I can be like, sweet, string input equals console.io dot prompt for input. Here's my import. Here's my class with its static method. Enter something. And for the purposes of this demo, I'm going to allow the empty string to be valid. Okay? So, let's create another method, public static int word count. It takes in a string. I'm just going to call it words. And it's going to create a word count int. And it will return that word count based on that string that was passed in. I'm making this a separate method because I don't want to just bastardize run and then we have to like erase everything and all that stuff, right? So I'm going to go ahead and get some input from the user, and I'm going to have int to make sure that we don't have collision of terms while I'm speaking. I'm going to call this num of words. Or you know what? I'll call it input words. How about that? Input words. And it's going to equal word count, passing it the input to be analyzed. Now, I'm only going to do that if... Actually, you know what? Here, hang on a second. Word count. And then I can say, inside this method of word count, I can say if words does not equal null and words.length. In fact, we'll do words.trim.length. So we're getting rid of just white space, because white space, while they are valid characters, is not a word, right? I won't do length here. I'll say words.trim is empty. We'll make sure that it's not empty, right? It's not empty. So it's not null, and when I trim the words down, it's not empty. I refer to that simply as trim empty, right? And it's not words. Words is not trim empty. If that's the case, then we'll do the following. Here is a string array. I'm going to call it words. And it's going to be equal to our... Oh, I can't call it words. No, I cannot. We'll call it words array. And it's going to be equal to the input we were given, which we just simply called, the string is words, dot trim, dot, because I want to get rid of all the useless space at the beginning and the end. Once I've done that, I can call the split method. And the split method wants to know, what are we splitting on? And so as it wants a regex string. And this is really, really simple because all we want to do is split on a comma symbol. That's it. That's all we want to do. So by passing in a string that has a single comma, regex, regular expressions, will go through, find all the times that comma occurs, and find every value to the left and to the right of that comma. And so, let's see. So when I do that, it goes to the first comma, and it reads all the characters to the left. That becomes the first value of this array. Goes to the next comma, finds every remaining value to the left. That becomes the next string of this array. And it does that over and over until it runs out of commas. If it runs out of runs out of commas, but it still has characters left in the string, those remaining characters become the final string in this array. So just to show you how this is working, and just so that you can see it in action, I'm going to go ahead and make yet another public static method. I'm going to make it void, and we'll call this print string array. And it will take in a string array. I'm just going to call it R, short for array. And then I'm just going to say, hey, if R does not equal null, then for every string S in the array, go ahead and just print that string right out to the screen so you can see it, okay? First, up here, I want you to know, well, that's actually going to be our word count, right? Word count is going to be equal to words array dot length. That's how many different strings I have based on separating them by a comma. And then let's see. I want you to see what this array looks like. So just as a point of testing, I'm going to go ahead and print the string array, passing in words array. So I'm going to do that first. Then I will save the length of that array to this word count, and then I'll return the word count. So just so you can see what's going on here, I get an input from the user at the console. Then I call the word count method, which is going to split that string based on commas. I'm doing this on purpose, by the way. I'm doing a comma separated string. And then, well, okay, fine. I take it back. If we're going to talk about words, words are separated by a single space. So we've got a single space character. Fine. We'll do that. And then I'm going to print out the contents of this array, one line at a time. And then I'm going to save the length of that array and return it. Okay, so here we go. Enter something. Hello. And I hit enter, right? Oh, sorry. I never actually printed out the number of words. Let's make sure that happens. Num of words. And then we'll have input words. Sorry, my bad. Here we go. Hello. And we get one word, right? That's what we wanted. Absolutely. Hang on a second. Let's do that again, except this time I'll do a space and hit enter. Ooh. That came back right though, right? I mean, I put a space in there, but there's no words. That's a good thing to know. Remember that I was also using trim back here, so white space gets annihilated, right? So I'm going to go ahead and say, fine. Let's do space, 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 hello, space, space, space. And again, with the help of trim, that comes out fine. If I hit play again and I'm like, hello, space, 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 world. Notice I've got 3 spaces here. They are not at the ends, so trim will not impact the number of spaces we have. If I then hit play, oh, sorry, that was the wrong thing to do. Oh, I broke it. There we go. If I then hit enter, notice it goes hello, and then there's empty string, world, right? Because it went hello, space, and then before there were any other characters, there was another space. So that's what this empty string is. Then, between the second and third space, there were no characters. That's what the second empty string is. After the third space, there was a word. It looks at this and says, hey, we have 4 words. Okay, so this is going to be a little weird, right? We could probably write some intelligent code to fix this. I'm not too worried about it right now. I just want to show you the behavior so you understand how split works. In fact, if I come back over here and I take trim off, right? Now I've taken trim off. By the way, just so you know, if I were to have a string array, I'm just going to call this temp, and I make it a new string array of size 3, and I don't give it any values, every value in that array is null. If I then say print string array, and I pass it temp, the array itself is not null, but its contents are null. This is what it looks like. Oh, bollocks, it didn't do what I thought it would do. I thought it was going to print nulls out, because usually when a string is null in Java, it actually says the word null, which is kind of annoying. Did they change that? I sure hope not. String temp, print string array, here we are. This stuff over here, boop, 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 boop. No kidding, it just came out blank. I did not expect that, folks. I did not expect that. I thought it would come up null. Let's test that really quick. Here. Let's do sysout null. Oh, cancel that. It won't accept null. Okay, fine. Fine. String temp equals null. I just want to verify what null prints out like so we know what it looks like. Well, I'll be darned. I swear to you, it used to print the word null. I swear to you that was a thing. Maybe they changed it. That's weird. All right. I'm okay with that. In that case, I'm going to drop a breakpoint down here. In fact, I'll drop a breakpoint right here. Because I want you to see what this array looks like when you have spaces but no characters. So, let's go ahead and run this. And we have space, 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 hello, space, 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 world, space, space. Okay? Oh, I didn't run it in debug. Let's run that in debug. 1, 2, 3, hello. We'll make it a smaller example. World. Enter. Okay. So now we're down here after the array has been created. I can hover over this array, and it will tell me that it has a length of 5. And when I expand these things, I can see, you know, here is... here's the value. It is nothing, right? Doesn't say null though, which is interesting. 805, 805. Ooh, actually, I believe these are null. They have the same address, same value anyway. We get down here and then see, look, this string says hello. It has a different ID, and then we have, or different value ID. And then here we have 807, which is world. But these guys have the same value ID. I believe these are actually null. In fact, let's do this. When we go to print, we could do this. We could do, oh, check this out. Let's do s equals null. Then we'll say in square brackets, so that we know what it is. Null. Like that, right? Otherwise, just print s. Look at me using a ternary. Yay! We love ternaries. Okay, cool. Stop this code. Rerun it. Enter something. Space, space, space. Hello, space, world. That's what we had before. And, okay. So these are not technically null strings. These are actually empty strings. Because if these had been null, then my logic would have grabbed it and would have said, yes, print this default string that says null. But it didn't. So what we're looking at is the empty string, not the null value. Okay, cool. So when a separator occurs and there are no characters, we get the empty string. But what I'm trying to show you here ultimately is that when I call split and I add some split character, assuming that I have been given good input, I will get an array where the number of strings in this array is equal to the number of words in the original string if I split on a single white space character, a single space. That's what split does. Take any separator, and then based on that separator, build an array of values where the separators are removed and every value on either side of that separator is given its own space in the array. This should help you with Hangman. Guys, like I told you like last week, string.split will help you with Hangman. It does not help you with setting up the puzzle. It doesn't help you with the underscores. It doesn't help you with that part. But what does it help you with? If you can do a split on a string and you can count how many words are in that string, what it does is it helps you validate that what they gave you was a valid puzzle. Because valid puzzles have at least 3 characters and they are 1 to 8 words inclusive. Now, when I say at least 3 characters, let's be honest, it really should be at least 3 alpha characters. Not special symbols, not numbers, not white space. It should be at least 3 alpha characters, okay? And then you have between 1 and 8 words. This will help you figure out how to count words. So that's why I'm showing you split. Okay. Sorry, my throat's a bit dry today. Alrighty. Let's see. Someone wrote, it is prompting for input before it reaches that line. Which line? I don't even know what you're talking about. Because my prompt for input is here. And then I get this stuff, right? So I don't have any other prompt for input. Are you talking about your code? Lord Snuckle, it is prompting for input before it reaches that line. I'm not sure which line you mean, and I'm not sure. However, the way I have it set up is the way I wanted it to be set up, so I'm okay with that. It's perfectly fine. But if I've made some other error, or if you're talking about your code, then please let's keep talking, because I'm fallible. I make mistakes all the time. All right, so let's go ahead and reduce these down. Just collapse them. And in fact, I'm going to make another method here just briefly. Public static void. And I'm going to say demo string split. And I'm going to move all of this code here into that method, because that really is what that demo is about. And collapse it down so it's out of the way. And push it out of the screen. Yay. All right. Let's see. What can I do? What can I do? Well, let's imagine for a moment. How can I show this? You know what's interesting about strings? Public static void. Oh, I hate when it does that. If I don't type fast enough, then it expands the other method. Void demo. Let's call it character. What do I want to call it? Demo character masking. Let's do that. Okay. So let's say for a moment, I've got string input. This will be, in fact, to be honest with you, I could just copy pasta the first line of this previous code, right? Using my control key, I drag, I drop. There we go. I've got a copy now. I can collapse this back down. I get input from the user. Let's say for a moment, just hypothetically, I want to mask all the vowels in a string. So for example, let's see, mask all vowels, and we'll define a vowel as A, E, I, O, U, but not Y. Mask all vowels in a string with the asterisk symbol. Okay? One thing that you need to understand about strings, and it can be kind of hard to see at first because the way that we use strings makes this not so apparent, but a string is completely immutable. What this means is that when I say string s equals hello, then remember that strings are a reference type. When I look inside the S bucket, I don't see the word hello. I see an address out to a spot in memory that contains the string that has the characters that spell the word hello. So my bucket only has the address to that string. So that has the address to that object. If I then say, in fact, here, let's make this a little bit more visual. So hypothetically, I have a string s, and it equals hello. Sorry, it equals the string hello. And then I say s plus equals, in other words, I'm going to concatenate onto it, space world. You know, we could look at this and we could say, let's just say hypothetically, this is at the reference or the address. We'll make it really nice and easy. Address 100. Okay. And this one is another string at reference or address. Let's make it 110. That actually refers to this string right here. In fact, let's make this a little bit more separate. Let's say string s2 equals, and then I will drag and drop this stuff right up here. So now I've got two strings. And what I'm going to do is I'm going to take the value of s2, I'm going to combine it with s, and then re-record it back to s. So to make this longhand, I would say the value of s concatenated with the value of s2, and I'm going to store that in my s variable. By the way, Lord Snuckle came back. He said when I was trying to print out the array itself, no, it wasn't. It was the way I have this set up. It prompts for the input first, but only once. This is the only place it prompts for input. Then I call the method called word count. Word count is going to go through and it calls print string array for me. Print string array is going to go through and do all this stuff, but I only prompt for input one time, and that's right up here. It doesn't do it anywhere else. All right. So going back to what we're talking about. Lost my train of thought. Here we go. So I'm going to take the value of s, concatenate onto it s2, and then store that back in s. Okay. You might think to yourself that when I'm done, it's going to be hello space world, and yes, it will be. And you might be tempted to say, hey, all I did was change the contents of the string at 100. But that's not true. That's not the case. We didn't modify the first string object. We made a third string object, and then we replaced the first string's reference entirely. In other words, we made a new object and then just forgot about the first. It looks more like this. The final string that you see here is actually another string at a different address entirely. And then we store that in S. Assuming that the first string is never used again, this address gets deleted and this string doesn't exist anymore. So that memory location becomes available again. So that's what happens with strings, is that they're immutable. They can never really change. And that's why when we call split, or if we use a replace method, or if we use an insert or concatenation or anything like that at all, while we are making a new string result, we are not actually modifying the original. We are instead building an all new, brand new string. And we're storing that address instead. That's why splits and two lower and two upper, they never actually change the original value. They just return a new string instead, because that's all a string can do. So when I pose the issue, so if you understand that concept, then when I say I want you to mask all the vowels, then you're going to be tempted to believe that if I say input dot replace, and we'll just start with a, and then we'll do the asterisk character, right? We'll do the asterisk character. That's going to replace all the lowercase a's, not all the capital A's, just all the lowercase ones. In fact, we could even, I think there might, is there a regex replace? Because that'll make this so much easier. There's a char sequence with a different char sequence. There might be a replace all. which takes in a regex, yes. Replace all takes in a regex. Here's what the regex would look like. It would be A, E, I, O, U, and then A, E, I, O, U with lowercase. That's how you specify any one character that you see in this list of characters. And the replacement needs to be, I think it's also a string, and we'll make it an asterisk. So if I do, let's do a sys out of this result, just so you can see it in action. Let's do a sys out of this result, and then we'll do another sys out of the original input again, so that you can see if it changes or not. Let's go ahead and in our run method, we will call demo char masking. And let's go ahead and hit play. And, oh, by the way, I'm going to go back to my regular Java perspective. I don't need debug right now. So enter something, and I'm going to be like, I love eating yogurt. That, I believe, has all of the vowels, A, E, I, O, U, and we're not going to mask Y, so it shouldn't mask Y. Then I hit enter. Notice the masking takes place, and it takes place correctly. It took out all of the capital and lowercase vowels. However, it's like the original input string never actually changed. If I want to make a more permanent change, if I want to make a mask that is actually like, okay, now the string no longer contains these characters, then what I'm saying is I want to replace these characters. I want to manage these characters. Or what I could say is I want to mask these characters for a time. And then over time, I want to reveal all the vowels of a certain type, right, of a certain kind. This is getting dangerously close to your homework assignment, but let me just show you how I might do this. This is great if I just want to mask the string, but you can see here that all I'm doing is creating a new string with character replacements. It doesn't actually do much in the way of dynamic performance of anything. It just masks the stuff I want to cover up. Okay, fine. So then, in that case, let's do the following. Here, what I can do is I can say, you know, instead of doing this little replace thing, which is good, I like the replace, but let's instead create a char array, and let's call it masked chars. And we're gonna build that char array from input dot to char array. So now, when I've done that, I'm going to go ahead and sys out my masked chars, just the array itself. Check this out. This is kind of interesting. You might remember, let's just do hello just for easy peasy. Look at that. I'm not printing the input. I'm printing the array. You may have seen in times past in my class, when we try to print an array, it tells us what type is in the array, it tells us that it's an array, and then it tells us the address. But not this time. And the reason why is because we're calling a version of print line that is an overload that takes in a char array. Java is like, oh, if you have an array of chars is the foundation, the spine, the backbone of a string. I'm going to go ahead and print this like it's a string instead of calling the toString on the array object itself, which is kind of cool. Because now, not only do I have something that prints like a string, like you see here, but now I also have something that allows me to reach in and allows me to change, let's do one, change a specific character to a different character. And then when I go to print that array, you can see that I've actually changed the contents of the array itself. So if I have a char array and not just a string, a string cannot change its internal characters. It can make a new string. It can't replace the characters it has. But then if I have a char array, I can change the contents of an array all I like. And I can mask out certain stuff. Now when I do that, I lose that original data. I lose the letter E as a character in this array. But don't I still have something I can refer back to? Yeah, I do. Yeah, I do. In fact, if I went on and I was like masked chars, and we'll take the last character, right? We'll take the final character. In this case, it is, let's see, character number 4, index 4. And we'll make that an asterisk also. Then now I've gone through and I've masked my expected vowels. Now I'm hard coding this, which is kind of cheating, but I'm just trying to show you a principle at work. I would do this more intelligently in other scenarios, in a more professional scenario. But I'm just trying to show you that I'm purposely masking out the second and the fifth characters. And I'm doing that with indices 1 and 4. Okay, so here's hello. Later on, after I print that, I can go through and I can say for int I equals 0, I is less than our original input.length, right? And then I plus plus. I can go through and I can say if, and for ease of making this work, I'm going to say, I'm going to actually store this char. I'm going to say, let's see, char key, that's the character that belongs to input, char key equals, and I'm going to talk to input. I'm going to make everything lowercase so that it's easy to check. And I'm going to do char at, and then the current index I'm at. And then if key equals A, or if key equals E, or, yeah, I know I'm making character for character comparisons, but that's okay. That's the way this is normally done. If you know what you're looking for, then you can compare against an expected value. I'm hard coding these values, but it would not be hard for me to get a value from the user at the keyboard and compare to that, hypothetically speaking. You know, no reason. And so if the key in the original string matches some character that I'm looking for, then I will go ahead and change that character to the key it matches, or to the character it matches. Now, I cannot tell. I should probably make this if-else if, right? Alrighty. But you get where I'm going with this. Hopefully you get where I'm going with this. If I know what character I'm looking for. See, I'm actually a little nervous showing you what I'm showing you right now, because I'm afraid some of you will confuse this and you will make a giant if-else if of 52 characters or 26 characters. No, don't do that, okay? I'm trying to show you a principle, not an approach to Hangman. I'm trying to show you a principle. And then bump that down, and then we just... So anyway, the point that I'm getting at here, I know what I'm looking for. I've only got 2 characters that I'm looking for, right? I've only got 2 characters that I'm looking for. So I'm going to go ahead and just bump this down to E and O. I don't really care about the other ones. You can see where I'm going with this. If the key is lowercase e, then in my masked chars array at that index, I want to set it equal to E. Similarly, if instead the key in the string, that character in the string matches the character O, I'm going to go into the array at that same index and replace the mask with an O. So now, let's see, I printed the masked chars before this loop. I'm going to go ahead and print the masked chars again. I'm going to highlight this, drag and drop with a control, drag, drop. And so now when I run this thing and I say hello, first it masks those characters in the array. Notice I'm never actually printing the input string. I let the user input something, but I never print the string itself. I print the array. So I build an array from that string using the toChar array method. I replace a couple of the characters with asterisks, and then I print that array. And that's what this output right here is. Then I go through the string character for character, since it matches in terms of length and it has an association of the characters in the string to the characters in the array. I go through the string character for character, and if a character in the string matches one of these two that I'm looking for at that index, I jump back into the array and I replace the array's character at that same index. So hopefully that makes sense. To give you kind of a visualization of this thing, my input would be like hello. The array, oh look at that, lines up nicely, would be like this, H asterisk L L asterisk. When it's masked, right? That's when it's masked. Then when I go through, what happens is I check this character. Is that E or O? No. This character, is that E or O? Yes. It is E. So using that same index, I come down into the array and I replace the character. Going back to the string, I go to the next index. Is that E or O? No. Is that E? No. Is that O? No. Is that E? No. Is that O? Yes. Go to that same index in the array. Replace the O. That's what that code does. Okay, now be honest with me. This goes back to cursed bless and to its riles. Now that you've seen that, now that you've seen taking a string and making a char array and then manipulating the char array based on the string, does that help you with your hangman? Hopefully it does. So string.split, and this goes back to Zane Stockton in Discord as well. So string.split helps me count how many words there are, assuming that the input was formatted correctly, that there are no leading or trailing spaces. I can always use trim to get rid of that. If I want to go the extra mile, I could make sure that if there's a lot of spaces in the middle that we annihilate those. I could code defensively for that, right? And so could you. Because in the sequence, in the case where there are multiple white space characters in a row, you only need one. So you could write some code. You could write some code to handle that case. And then once you have a properly formatted string, you can call string.split. That will create an array of strings based on how many words are in the original string. That's how you can figure out how many words are in the puzzle. Once you have validated that the input is in the right format and it has an acceptable number of words and an acceptable length, then you can create a char array that is the state of your puzzle. That's the one that holds all of the underscores, all of the correct spaces, all of the punctuation, all of the numbers, right? It has the puzzle in its starting state. And then as you make guesses, you compare those guesses to the original string, and then based on the index of those characters, you can come back into the array and replace the underscores with the characters that were guessed. If I were you, here's a pro tip. Here's a pro tip, guys. Pro tip. I wish I had like a pro tip that comes up on the screen, but pro tip, okay, so here's pro tip. Normalize the data. And what I mean is when you get a puzzle, make it all lowercase or make it all capitals. You don't have to maintain casing as the user gave it to you. You're allowed to make it all caps or all lowercase. Typically it's done all caps, right? You can do that. That's perfectly fine. So consider that as you're making hangman, okay? Normalize the data, validate the data. Once you have good input, you can use split to count the words and a char array to manage the state of your puzzle. You can just compare it to the validated and proper string to figure out which characters to unveil. It's not hard. A lot of people make hangman way harder than it has to be. Way harder than it has to be. And it's really a question of experience. What things have you done before? What do you know you can do versus what you can't do? So I'm trying to throw you some bones here that will help you get through hangman a little easier. Okay? Awesome. All right, so if there are any other questions, please sling them at me in the questions channel. Past that, I don't see anything else for Hangman to discuss right now. I've gone through Mr. Stockton's, Cursed Blesses, and It's Ryle's comments and addressed those directly. There's nothing new in the Twitch chat. And we've got a little bit of time left. I'd like to jump back over here to UML for a moment. Even if we don't finish this diagram, I want to give you an idea of what this looks like, right? My movie collection manager is going to be the brains of the operation. And my movie collection manager I don't need more than one instance of my movie collection manager, right? So because I don't need more than one instance of my movie collection manager, I'm going to treat this class very much like it's a static class, meaning that all of its members are static. I don't need more than one movie collection manager at this time. I might change my mind about that. I might decide later in life that I want to do saving and loading, in which case having an instance of movie collection manager might make a lot of sense. You know what? Now that I've said that out loud, a movie collection is no good if you can't save and load it. So you know what? I am going to make this an instance class because it will allow me more easily to write the collection out to memory and then read it back in. So yeah, let's keep this as an instance class. I suddenly like it better. All right, so this class needs to have like a run method or an initialize method, something that says get started, right? So I want to make a public instance method, and we're just going to call it startup. Startup can be a noun, but can also be two words that are a verb. Start up, right? A verbed phrase. Startup as a single word, as a compound, is a noun. So start up, and in this case, I'm going to go ahead and just keep this void, no parameters. That method right there is what main is going to call. And this is going to be an instance of this class because this class is not going to be a static class after all. Because of that, I know that main is going to call at least one member, in this case startup, of the movie collection manager. And in order to do that, it's going to have to create an instance. But you'll notice that the driver class does not have any data fields. It doesn't store any instances long term. Chances are it's an instance found inside the main method. Anytime we know ahead of time that we want some instance of a class inside of a method, but it's not going to be part of the class, like main but not part of driver, that's what we call an association. And an association is very interesting. I'm going to drag this arrow out here, and you'll notice that the arrow has two heads on it. We're going to go ahead and erase one of those heads by removing the greater than, greater than symbol. Is that right? The less than. No, less than is on the left. Gosh dang it. Yeah, it is the greater than symbol. So we remove that symbol, it removes the arrowhead. Then this is an annotation. We're going to change that in just a moment. But we're going to point this arrow at the object being used by driver. And here in this annotation, we get to say what kind of association this is. An association is the weakest kind of relationship. In fact, what's really funny is that as we talk about UML stuff, we're going to talk about the relationships between objects, and you're going to start to hear that it sounds almost like a romantic type scenario and the different levels of interpersonal relationships that we have. The association, or the associate, I'm associated with this person, I'm acquainted with them. That is the weakest relationship, right? And in this case, we're going to have an instance of movie collection manager for just a brief period of time. We're going to use it and lose it, right? So that means since we have an instance of that we're going to be using, we're going to say that this is an instance of. In fact, I think I usually see instance of, no, let's do two words. Instance of. Driver has an instance of movie collection manager for just a short period of time right inside this main method. When this main method is over, this object goes away. It's not stored at the class level. It's stored as a local variable. So that's an instance of relationship. Even worse than that in terms of like strength of relationship, this is the second weakest level of relationship. The absolute weakest, I'm going to go ahead and double click this to make a clone. And we're going to drop it here. You see, I'm going to space this out for readability. Come on. Oh my gosh. This is killing me. There we are. That's good. This is interesting. Movie collection manager is going to be calling methods from console.io. But everything in console.io is static. That means there is no instance of console.io. That this class just uses methods from console.io. So here comes the weakest relationship of all types. This is the uses relationship. In other words, Movie Collection Manager uses console.io for its members and never even makes an instance of it, never owns it, never manages it, just says, hey, I'm going to tell you to go do stuff. I'm going to use you for what you can do. And that's that. So Driver at least makes an instance of Movie Collection Manager so that it can call instance members. It at least holds on to the object for a while. So it has an instance of. But Movie Collection Manager is only calling static members. So it's only using console.io. So this is a uses relationship. Over here is an extremely strong relationship. This is the Jerry Maguire of relationships, right? Movie is composed of, it's made up of MPAA rating. So when we use this diamond on a stick, what we're saying is that movie turns to MPAA rating and says, you complete me, right? That's what an aggregate, that's what a composition relationship is, or an aggregation relationship. You, the smaller class, complete me, the larger class. You help make me up. Without you, I can't exist. So that is a much stronger relationship in UML. So weakest, I use you. I don't even have an instance. Second weakest, I have an instance of you, but I'm just going to throw it away when I'm done. Among the strongest is composition and aggregation. I'm just going to call this composition for now. Is composition, you are a part of who I am, right? So yeah, these relationships are very interesting. And of course, a movie collection manager is going to have some collection of movies, right? Now, we haven't learned about this in our class yet, but I would have a data structure here. I would call it movies, and it would be a data structure of type array list, where that array list stores movie objects. We haven't learned about what this is yet, but you know how arrays cannot change in size? Imagine if they could. That's what an array list is. And we'll talk about the nitty-gritty of how an array list actually works, how it's really managing an array, and whenever it needs to change in size, it does some magic behind the scenes, and it makes new arrays and all that stuff. We'll talk about that in nitty-gritty detail later in life. But suffice it to say that if I have a collection, that collection is going to change in size over time. I'm either going to add a bunch of stuff to it, or I'm going to remove stuff from it. I need this to be a data structure that is dynamic in size, but I still want the rapid access speed of an array. So I'm going to have an array list, which is dynamic in size, but has rapid access like an array, and we're going to call it movies. No one outside of the movie collection manager needs to have access to this movies object. So I don't have a get and I don't have a set on purpose. But I'm probably going to need some other methods. I'm probably going to need stuff like, we're probably going to need to have like add new movie, which is going to be its own process. And maybe that method returns a Boolean representing whether or not it can actually add the movie to the collection. Is it not a duplicate? Does it meet all the requirements? Blah, blah, blah. And then I might have a create movie method. This method is going to be the thing that actually goes about the process of getting the information from the user, so we can create a new movie object, and that's going to return a movie object when it's done. So add new movie will call create movie. We might have some validation logic in there. We might not. We are definitely going to need update movie, and that's just going to be void. We're going to have a delete movie. And that one is going to be, let's see, I usually return the movie object that was removed from the collection so that we can report on it before it's gone. It also allows us to create undo logic if we ever need to. And then we need to have get movie, as in singular. And we might have different versions of this. We might have one that searches by ID, which is an int. and it returns a movie, which could be null if the ID doesn't exist. We could have get movie, and it searches get movie by title. And this would actually return a collection of movies based on movies that have this title, right? Unless it's like exact title or whatever. We could go through this. We could come up with a whole bunch of versions of getting a movie, right? For right now, let's just do title string, and it will return a collection. Let's just say it's a movie array based on how many movies have that exact same title. For example, Halloween 1978 versus Halloween 2018 are two different movies with the same title. You also have the movie Twisted in 1999, 2000, 2001, something like that. And then there were other movies, horror movies later on called Twisted. There are lots of movies that have the same title, or there are remakes. Psycho, 1960, whatever it was, and 1998, I believe it was. Something to that effect. Okay, so get movie by title may return a collection of movies. And then we have get all movies. And, well, to be honest with you, we've already got the collection here. Do we really need to go and get that collection? Probably not. But we might want to have a save movies method. And we might want to have a load movies method, where these methods are designed to take the collection as it currently exists and persist it to some data file. And then when we start up the application again later, we can choose to load. Chances are we also need to have some sort of main menu method, right? Some startup menu. In fact, I'm going to do startup first, and then we'll do the main menu method, which is going to go about calling other stuff. And so we could go through, we could argue this back and forth. We could say what's useful, what's not useful. We could say that we need to have some other features that don't exist yet. But I'm just trying to give you an idea of what this looks like, mostly because what you should notice by now is that there's a data field here that's of a collection of movie objects. And whenever we have one class or object that is made up of another class or object, we need to express that relationship. And it's this relationship right here. Remember, this is the one that says, you are a part of who I am. You complete me. So here's a really simple diagram, and I'm not even sure that we're really done with Movie Collection Manager yet, but that's not the point. The point is, here's a really simple diagram of what a Movie Collection Manager might start off looking like. We have a driver with a main that temporarily creates an instance of Movie Collection Manager so that it can call the startup method. That startup method is, of course, going to take over the show. It's going to call main menu to get some ideas of what the user wants to do. It's going to call these other methods to get those things done. The Movie Collection Manager is going to lean on the console IO library for console input and output. The Movie Collection Manager is made up of a collection of movie objects. That movie object is just a POJO, and it has strings and an int, but it also has a very special enum type value, which means that the movie object is made up of this enum. So we have this enum down here. This diagram, as you see here, this is a good start to what a simple console movie collection manager might look like. Now, just to kind of give you an idea, if I hold the shift, let's see, if I click first, then hold, if I click, then hold control, no, control, then click, there it is. Control, then click makes a lasso. It will select all the objects that fall at least half of 50% into what I had, right? I can also just hold the control key and select click to grab the objects I want. Once I have the entities selected that I want, I can come up here to File, and I can say Export As. And then I can do something like PNG or JPEG and or PDF. There's PDF. I can do PDF. And I'm just going to go ahead and let this be the PDF thing. And I'm going to hop back over into where I've stored this stuff. Let's see, that would be here, teaching material, under design. And then here's that PDF I just made. If I open this thing up, you can see that the PDF only contains the selected entities. It doesn't contain any of the notes. If I had not selected these individually, if I had not highlighted the ones that I wanted, if nothing was selected, if I had done this instead, if I just clicked out here and nothing is selected, and then I did the exact same export, I'll do this. It'll say, yes, I want to overwrite. An error occurred. It's being used by another process. Didn't I close it? Oh, I guess I didn't close it. I'm sorry. Let's try that again. Export as PDF. Do this. Overwrite. It was cool. I open it up. Now you can see the PDF contains absolutely everything that's in the diagram. And the other thing I like about it is that it will zoom in as far as it can. If there's a whole bunch of other entities, it's going to zoom out so they can all be on the same page together. But being able to select certain entities and print just those can be super handy, especially in giant diagrams where you want to show just the database, or you want to show just the front end, or just the core, or just the models. You can select just the ones you want and then create sub-diagrams. Okay? So there you have it. This is a very basic UML diagram. There are probably some other elements that I would add to, or even maybe some that I would refactor or remove entirely. But I just want to show you the basics, how one class can use another, or can temporarily hold on to an instance of another, or can acknowledge that it is made up of another, like movie collection manager is made up of movie, and movie is made up of MPA rating. This is super duper helpful because when it comes time to actually code this up, I can come back over to my code and I can start my new project, right? I can, just to kind of give you an example here, I've already got, well, here, let's do this. Let's do a new other project where we make a simple project that is part of this video demo group, and we're going to call it movie collection demo. Hit finish. And then movie collection demo, I know certain things to be true. I know that I need to have a driver, I need to have these guys. In fact, if I'm really smart about this, I can also take time to indicate which package each of these items is in. Right? I can say that this is the app package, for example. Conversely, instead of making a package that wraps around, because I could then come in here and I could say, well, you know, this is a model, and this one down here is an enum. And if we had more than one class in the same package, I could use this package to kind of group them together, right? But alternatively, as I did over here with console.io, I can choose instead to add the package to the names of these classes and types. Yeah, it extends the name out a little bit. May even make it a little less readable. I prefer to wrap them in packages, but this is one way I could look at this. And I could say that this is enums dot, and I could say this is models dot. You know, I could do that, right? And then based on this diagram, if I have that information, I know that I need to make a driver class in the app package with a main method. I know based on this diagram that I need a controllers package with a movie collection manager class. Movie collection manager. And that's going to be in my controllers package. I know that I need to have, based on this diagram, I need to have a models.movie. So I'm going to go ahead and say new class, and we'll say movie, which is in the models package. And then finally, based on this diagram, I know I need an MPAA rating enum in the enums package. We didn't, I didn't list that out, but we talked about it just a moment ago, so you should get the concept that there's this package called enums, right? And it's going to be MPAA rating. So now I have all the packages I need, and I have all the classes and types, all the classes and enums declared that I need. If I look at this diagram, I could say, well, you know what, this is really easy to implement right here, so let's go ahead and get that done really fast. And I can go into MPAA rating, and I can, you know what I can do is, since we did this in the proper convention, I can just copy it in pasta. There, that's my enum, right? Movie, I won't be able to copy pasta so well. I could, and then just rearrange stuff, right? But I can also just look here. I can look at this stuff and I can say, oh, okay, we have a private, we have a private final string called title. And we have a private final int called year. And we have a private not final MPAA rating variable called rating. And we have a private final string director, right? I'm going to do Control-Shift-O to get my imports for my types. These are all in an error state because they are finals and they haven't been set yet. But I know that I've got to have a constructor, right? So I'm going to do a public movie. And actually, I'm going to cheat a little bit here. I'm going to use Java. I'm going to use Eclipse to my advantage. I'm going to go to source. I'm going to do generate constructor using fields and hit generate. And this generates a constructor for me that has the string, that has the title, the year, the rating, and the director. And notice that that's actually how I declared it in the UML. Whichever sequence appears in the UML, that's the sequence you need here because you got to stick to the plan. People expect you to stick to this plan. So if this is not the same sequence that Eclipse generated, then you got to fix the sequence to match the UML or vice versa. But I suggest matching the UML. So now I've got this. You're not going to know what the super means right now, and right now we don't need it. So I'm going to go ahead and get rid of that. Also, we are going to have an MPAA rating thing, right? And so we are going to have a set rating in just a moment. I can, since these are private, I can cheat again. I can do a right click and I can say source, generate getters and setters. Since these are finals, you'll notice they only offer gets. The rating is not a final, so it has both. But the others are finals, so they only offer gets. I'm going to go ahead and select them all. And generate, sort by, let's do that. Generate, okay? And then right here where it says rating, I'm going to say set rating, passing rating in. Because remember, if you have a setter, you should use it. If you have a getter, you should use it. And the UML calls for a toString. You'll notice that I am doing some implementation here, but this is very generic, basic implementation. I'm not really comparing this to any business logic yet. It's just whether or not these fields are final. Real implementation comes later, but I need to at least stub out the class. And so I'm going to go ahead and I'm just going to stub out the toString. I'm not going to use the generic. I'm not going to use the auto-implemented toString because that's got a lot of implementation and I don't want that right now. So let's do public string toString. And then right now we'll just return null just to satisfy the compiler, right? So this is the movie class, which is a POJO, and it's almost entirely implemented. We just got to fix the toString basically. The movie collection manager is going to be different though, because I really am just going to stub out these methods with generic returns if they're non-void. I'm not going to put any logic anywhere. And we're just going to have all these as stubs. But you can see that based on this diagram, it's really easy and fast to set up my classes and my types. It's super easy. And then once I have movie collection manager stubbed out, I'll be able to basically fill in the blanks. Once I know what the implementation should be, I can do my pseudocode, and then I can just fill in the blanks, much like we did with console.io, where I gave you the class file, right? I'm just going to make stubs, and then I'll fill in the blanks later. That's what UML allows me to do, and it'll let me think through the architecture first so that I knew how the objects interact with each other, and I could ask questions like, how is movie collection manager going to set movie up so that it has its values? And how is it going to get those values so it can print them out? I was able to ask those questions and answer them with the diagram that we created. All right, it's 3 o'clock. We've covered UML in its basic form. A fair amount. We've also covered how to export that diagram. We got to talking about Hangman specifically and how we can take a string and use it to create an array of chars very easily. How we can use that string as a reference for how we modify that array of chars. We talked about all of that stuff. We talked about how we can use split to figure out how many words are in a properly formatted string. So take this with you. Use it to your advantage. Review this as much as you want. If you have any other questions, you can feel free to message me on Discord or on Twitch. I will get those messages as well. And you can let me know if you're stuck on anything or if you'd like me to go over any other information. But until next time, you guys are awesome. Thank you very much. And remember, be epic. Don't suck.